Hello, hi everyone. My name is Pushpinder Malhotra. I work as a senior QA automation manager for Northbridge Financial Corporation. Thanks, Parasoft, for giving me this chance to speak on how we are using Parasoft for our API testing and service virtualization. And I'll talk about how we have used to increase our productivity and deliver ROI. The agenda for today's talk is briefly introduce us as Northbridge. We'll talk about what are the challenges that any organization or team faces in their DevOps journey. What are some of the key factors of successful automation? How we are using API testing in our ecosystem, what KPIs we are using to measure our success for API testing. What is service virtualization, how we used it, and what are the KPIs for service virtualization that we use to measure us. So about us, a little bit about Northbridge. Northbridge Financial is a leading insurance group. It's a commercial insurance group that helps Canadian businesses for their property and casualty businesses. And we develop applications that rely heavily on third-party APIs. We have implemented AI-powered test generation and execution frameworks for better scalability. We'll also talk about service virtualization, how we have used service virtualization to simulate those third-party APIs, which sometimes are down, and that enhances our team's productivity while minimizing the costs and dependencies. And we'll talk about what are the criteria or what are the KPIs that we use to measure the coverage, the defect detection, and the environment stability for our test cases. So let's talk about some of the challenges that any team or organization faces in their DevOps journey. The first one being the cultural resistance. The adoption of DevOps requires a significant cultural shift, and there may be resistance from some team members who are used to work in silos. It is essential to get everyone on board with the DevOps philosophy and encourage collaboration and communication. So then comes the tool integration. So whenever we bring in a new tool, for example, when we brought in Parasoft, we had to ensure that the existing tools work seamlessly with Parasoft in terms of your code repository, that Parasoft can, we can integrate the Parasoft code into our code repository, which is Azure DevOps in our case. Then the pipeline, so we can integrate Parasoft into our Azure DevOps pipeline. So we have a seamless integration. Then we can pull the metrics, pull the reports, dashboards, all of that. So it's a challenge. It can become a challenge that when you adopt a new tool, you have to ensure its integration between various different tools. Then automation. We need to identify what tasks we really want to automate and ensure the automation is scalable and reliable. Sometimes the organizations start focusing on automating everything, and then they basically set themselves for failure because it's not possible to do 100% automation. It's very important to understand how to automate, where to automate, what to automate. So it's important to have a strategy that what task can you really automate. Security is another aspect. Sometimes when we are bringing in new tools and techniques and we were trying to do things, we forget about security, but it's important that we, everything we do, it's secure, right? It's integrated. Security is integrated into every single step of the process. Monitoring and metrics, very, very important. We want to monitor the entire process and we want to collect the metrics to identify our areas of improvement. So we know how we are doing and what are the gaps, how we can improve that. So it's important that we collect those metrics and we understand the progress we are making and the gaps that we have. If we understand these challenges and we try to implement solutions for all of these, it gives us the benefits of faster, more reliable software delivery. Let's also talk about some factors for successful automation. If we look at this pyramid, I'm sure most of all you are familiar with this pyramid. We want to ensure we are focusing very less on the manual test cases, a little bit more on the UI and good layer on API, a lot more on the unit test cases. But we see the reverse sometimes. The teams are not doing unit test automation. The teams are heavily focused on the UI test cases using Selenium and less focus on API test cases as well. So we need to ensure, teams need to ensure that they know which areas make sense for automation. You cannot always be doing 100% of manual testing or 100% of Selenium-based testing. We need to ensure we are focusing on all layers of automation, all layers of the application architecture. And then it's important we have a scalable framework. So, but that means it should be, your framework should be in such a way that all team members should be able to use it. When we first started, we started using some C# libraries and started doing our API testing using C# libraries. And we did not have a proper skill set who knew how to create a framework, how to use it so that it can be used by other team members as well. It was, one person doing it and only that person knows what has been written in the code and only that person can do the API testing. So it's very important that we have a solution that can be easily used by every team member. Because if we want to do more automation, we want to involve more team members. And if you want to involve more team members, your solution should be easy to use. You should have a proper regression strategy with proper test selection. So again, we cannot start taking a look at every single test case and start automating. We should have an approach, like a data-centric approach, where we can keep our stuff in the Excel spreadsheets, all the data that's needed to be tested, all the combinations that needs to be tested. And then your framework or your scripts, you write once, you execute multiple times. That's how you can achieve more coverage and more successful automation. Again, you can have your UI test cases and API test cases in combination. You can focus, some 10%, 20% on the UI test cases, which tells how a user would use it. But then most of the testing should be happening through your middle layer, which is the API layer. Again, once you have done this, once you have built this automation, now it is important to schedule your runs. So your CI/CD pipelines are very important. We are using Azure DevOps pipelines for our CI/CD integration. And then how do we measure it? We want to ensure we can count on the coverage, right? We do not want to count on the number of test cases that we have automated. We want to ensure that all the functionalities, all the coverage is covered, right? Like all the functionalities are covered. So, so we need to ensure we have proper metrics, proper monitoring tactics in our in the tool, whatever you use, whether you use Jira, Azure DevOps, or HPLM, we need to have proper dashboards to have a proper metric support. And we need to rely on all layers of the software to do automation, not just a UI layer. As we see from, we'll see in the next slide here, if you see the number of APIs that are being used in different sectors, every sector, like financial sector, has 508 payments, e-commerce that are exposed, that are public APIs. So there are a lot of APIs that are being developed, and this is an old stats, like from 2009, 2013. So we cannot miss on testing APIs. It's important. Why it is important? We can easily find our defects early in the cycle. Developers can fix them. We don't have to wait for the latest sprints when the UI is developed. That time we are testing. So we can really test early. We can find defects early. We can provide faster feedback. So once the defects are found early, you can have your developers fix them quickly. It improves your software quality, right? API testing can help ensure that the application is reliable, it's consistent, it behaves as expected, and it leads to better software quality. It's less expensive than UI test for sure, because it takes a lot of time to build the Selenium test cases versus your API test cases, if you have proper tools for sure. Better integration. So it reduces the risk of integration issues in production. So if because with APIs, all you're doing is basically integrating the systems. So if you are testing at an API layer, then that means you are solving the problem of your integrations, right? Then you wouldn't see those issues in production. Improved security, because you can also do security and performance testing on the API layer. So that way we are building now security into that layer. I'm going to talk about what is our use case for API testing. The first use case that we started with was broker connectivity, a solution that builds a direct integration between broker management systems and our systems at Northbridge. So the broker management systems were going to request a quote in real time from Northbridge systems, where we at Northbridge were supposed to send a quote back to the brokers within 2 minutes. Before this project was done, everything was manual or on email. The brokers would send a request for the quote and we will send them back in a day or 2 days. But then we want to build a real-time online quote creation process. This meant that we needed to integrate between our systems and the broker system. So we had to do a lot of API testing there because we were building services, we were building integrations, and there was no way we can test without that integration. And there was no UI, there was no front end that testers can really use in that case. So we had to, this was our use case, and then this is when we got Parasoft into Northbridge, and we were very successful in building our testing infrastructure here. Then we got another use cases, which was certificate testing, CRM application. A lot of these use cases came into picture throughout the years, and we have been doing API testing on these. So the benefits that we saw out of all of this was the time it takes to create API test scripts versus create UI scripts is much lower. So it really increases our efficiency because the creation time is reduced, the execution time is reduced, right? And the test cases execution time is consistent, it's reliable. It's not like the UI test cases where today the test cases are running like 5 minutes, tomorrow it might take 5.5 minutes, 6 minutes, depending on the slowness of the application. It's much more efficient, much more effective approach when it comes to web applications. And it significantly reduces the time and effort required for testing, allowing testers to focus now on more critical areas of the application. So definitely, 100% we need to do API testing. We see the benefits of API testing. And nowadays, because the architectures are not monolithic anymore, and they're all built on microservices, so ensure that we have proper tools in place to get to do proper API testing, be successful there. So how do we measure we were really successful at what we did? We measured our test coverage. So if we were not to do API testing, we were just to do UI testing, we would not be able to get the coverage that we really hoped for or we really wanted to get into. Our test coverage actually increased to 80%. Because now we were able to do much more data combinations than if we were to do it through the UI. Our test creation time also reduced by 60% because once a team was trained on doing testing, it was very easy and quick to create test cases in Parasoft versus UI. This is in comparison to UI. Test execution time reduced drastically by 90% because any workflow that we do through UI takes around 30 minutes. However, the same workflow when done through API is done in 30 seconds or maximum 1 minute. So that's the beauty. That's the beauty of this. Testing efficiency increased by 40% because we were now able to, find our defects early in the cycle, early when we are doing API testing without even having our UI layer. So it really increased our efficiency by 40%. And testing costs, delays, all of that reduced by 30%. So we really definitely saw a lot of benefits. And these were the metrics that told us, okay, yes, we are doing something right in this sense. And then why service virtualization? Let's talk about what is service virtualization. So it's a technique that enables developers and testers to simulate the behavior of dependent systems or components that are not yet available or are difficult to access, so that testing can be performed earlier in the development lifecycle. So we often have dependencies in the software development, on external systems, on services such as databases, APIs, web services, third-party components. And these dependencies may be unavailable or unstable during the development of testing, making it difficult to test the application thoroughly. It addresses service virtualization basically addresses this problem by simulating the behavior of these external dependencies, allowing developers and testers to perform testing earlier in the development lifecycle with more control and predictability. It can be used for various different types of behavior, such as response times, error conditions, data variations. So by simulating these behaviors, we allow developers and testers to test their applications quite early in the cycle, reducing the risk of costly defects in production. So then what was our use case for service virtualization? So I come back to our, again, the project of broker connectivity. So we were going to build the APIs between these two systems, and we knew we were going to do the API testing. But now the other system was also being developed at the same time when we were building our own system. So there was no input from the other system that we could use to test our system. It was all going on in parallel. We were building our system, they were building their system, and we were building the integrations, but then we didn't know what was going to come from there. So they gave us some kind of structure, and then we mimicked that structure. We virtualized that structure in Parasoft. We created that XMLs and whatever was the fake request or the response, basically. In this case, it was a request because it was an intake request that we were expecting. And then we wanted to check whether we can send a code back to them within 2 minutes or not. So that was the best use case because we wanted to do API testing. We wanted to virtualize those services. And this time, it was not just the QAs or the testers that needed, it was the developers as well. They needed to test their system too for unit testing. So they used virtualized service as well. That was our one use case. Then we had another one called DMTI service. This is called an address validation service that is basically used by all our applications, all our environments, be it QA, be it dev, QA, UAT, staging, all the lower environments in various different projects use this service to find whether the address is right or not. And it's an external third-party API. And we had a limitation of hitting it only 1,000 times a week. If we would hit more than 1,000 times, then it's costly. Like we have to pay like $1 a hit, something like that. And this becomes a bottleneck just after, a week starts like on a Monday, everybody hits the service. It's like 1,000 times hit, and then we are done. We cannot hit it further or we bear the cost. So then we wanted to virtualize this service that ways our automation test, performance tests, our unit test, our QA testing can happen on the virtualized service, while business can actually use the real service to do their testing. So these were some of the original cases that we started. And going forward, going over the years, we had a lot more use cases for virtualization. We had Firescore API, a town grade API that sometimes goes down here and there, and that blocks our teams. So we have virtualized those services. Anytime we need to use the virtual environments, those are available. Developers redirect to those services and do their testing. The KPIs that we use to measure for service virtualization is test coverage, right? So we figure out that if we have actually increased any test coverage using the virtual environments. And we did find that we increased by 30% because there were test cases that we would not be able to do any testing if we do not have the virtual environment or the virtual service. Defect detection rate also increased by 30% because now if we are doing that testing early on with the virtual services, we are able to find defects in the code. And service availability time. This is the key, right? Like if the service is not available, then everyone is blocked. Like your developers, your QAs, your BAs, they're all blocked for a day or so. And then imagine the cost of, at least 5 to 6 team members for a day. And if we virtualize the service is always available, and we increased the service availability time at least by 90%. And sometimes it happens, the servers are down, and also our virtual service goes down, but then it's quick turnaround, right? Once we know it's down, we can quickly bring it up. So yes, at the end, I want to say Parasoft has helped us quite a bit in implementing our solutions for API testing, service virtualization. It has enabled all our team members because it's easy to use and they provide good support. Thank you very much, Parasoft.